viewers, welcome back to my YouTube channel. Today we are going to start a new video series on Azure AI fundamentals, exercises or hands-on. In this series, I'll be showing you one by one how we can work with Azure AI offerings like Azure Machine Learning, Automated Machine Learning Studio, then computer vision, regression, classification, clustering, text analytics, image classification, object detection, facial recognition, optical character recognition, then form recognition, speech translation and speech recognition, then language understanding, question answering, knowledge mining, generative AI with Bing Copilot, and content safety studio. So all these topics we'll be covering one by one in each of these videos. So follow my channel and I'm going to post the videos for this Azure AI fundamentals hands-on one by one to my channel, which you can follow to learn these topics. Today we are going to start automated machine learning in Azure ML. That would be the first topic of this video series. So I have opened this in a new tab here, and here we'll see how we can use automated machine learning feature in Azure Machine Learning to train and evaluate a machine learning model. We will deploy a machine learning model, test and train the model. Okay, training and testing that model for our purpose. Okay, next, what we need is a Azure subscription with administrative account or administrative access. Okay, if you have a trial uh, account created for you, Azure subscription trial account, then that will help. In the next section, we have create an Azure machine learning workspace. So to work with machine learning, we need to provision an Azure machine learning workspace in Azure subscription. Then we'll be able to open Azure Machine Learning Studio to work with the resources in that Azure Machine Learning workspace. To create a Azure Machine Learning workspace, we have to go to Azure portal using this link and sign into that Azure portal and then create Azure Machine Learning resource. To create the Azure Machine Learning resource, we need to create a subscription or select the subscription, then create a resource group, name the Azure Machine Learning workspace, select a region closest to our geographical region for less latency. Then storage account, key vault and application insights will be by default created for us or selected for us, which will be provisioned while we provision Azure Machine Learning resource. And container registry will be set to none. So let me go there. I'll click on create a resource, search for machine learning, and here I can see Azure Machine Learning. I'll click this. I'll click on create, and this will present me a form to fill the details. Here I'll select resource group ML workspace. I'll give the name machine learning workspace, and these are the storage account, key vault, and application insights, which will be provisioned newly for us. And then container registry is none. I'll click review and create, and validation is passed now. So I'll click create, and here we can see initializing deployment. So submitting the deployment template for resource group. Let's click on this link, and here we can see ML workspace is being created. Let's go to this resource group, and now we can see machine learning workspace is created along with the storage account, key vault, insights. Okay, all these resources, application insights, log analytics, everything. So let's go to the workspace and let's launch the Azure Machine Learning Studio. Now we are into Azure Machine Learning workspace, where we have opened Machine Learning Studio, and we can see so many offerings. We can create Jupyter Notebook, automated machine learning. We can design the flow like test or training based on algorithms we have or models we can create. And then we have the data section where we can upload our own data for test and training. Here we will have models. In the endpoints we'll have endpoint and the key to expose our models as a service. And there we have compute resources and clusters, data labeling option, monitoring of the model, and then environment and pipelines to set up the different environment for automated machine learning. And then these pipelines will be used for the uh, release to these environments. Next, let's go to hands-on back. So we are in the Azure Machine Learning Studio. Okay. In the Azure Machine Learning Studio, you should see newly created workspace. If not, select all workspaces in the left-hand menu and then select the workspace you just created. So basically, in the all workspaces, if we click, it will show the currently created workspace as well as if there are any more workspace. We'll go to this one and we'll be again coming back to this page. Next, enabling preview features. Some features of Azure Machine Learning are in preview and need to be explicitly enabled in your workspace. In Azure Machine Learning Studio, click on Manage Preview Features. So here we have all the options enabled. So let it be enabled. Enable the following features, preview features. Guided experience for submitting training jobs with serverless compute. So this one, guided experience for submitting training jobs with serverless compute, that is enabled already. Here we can see all the options are enabled. Preview, like consume data assets in your code, create compute instances using optimized creation wizard. So all these options are enabled. These are in preview mode. Moving on to the next step, use automated machine learning to train a model. So in this section, we'll be automating machine learning, and this will enable us to try multiple algorithms and parameters to train multiple models and identify the best one for our own data. In this exercise, we will use data set of historical bicycle rental details to train a model that predicts the number of bicycle rentals that should be expected on a given day based on seasonal and meteorological features. Now, data that is used is derived from the capital bike share and is used in accordance with the published data license agreement. So that's citation of the data from where the data is taken. Okay. Now in Azure Machine Learning Studio, view the automated ML page under authoring. So under authoring, we have automated ML page. Let's go there and then create a new automated ML job with the following settings using next as required to progress through the user interface. Job name should be MS Learn Bike Auto ML. Let's copy that. I'll keep this side by side for now. Job name should be this. New experiment name should be this. Description, automated machine learning for bike rental prediction. Tags, will keep it blank. In the task type and data, we have to select task type as regression. Create a new data set with the following settings. Data set name is bike rental, historic bike rental data. That should be our description. And type would be tabular. Then in the web URL, let's click next. So data source would be from web files. So it will be directly pulling data from web files, and we have to pass on the URL of the data, that is this one. Then we have to skip data validation. Here we are not doing any validation on data. Next, in the settings, we have to set file format as delimited. Delimiter is comma, encoding UTF-8, and column headers. Only first file has headers. Skip rows, none. Dataset contains multi-line data. We do not have to select this. So out of those files, this Azure ML wizard, or basically this process, was able to find out what was the file format delimiter, that was comma, and the encoding as well. Only thing we have to change was column header. This all we are doing so that we can identify the columns and the data properly within our data set. Okay. This will build an schema basically, okay, with all these details. Now include all the columns other than path. So we have skipped the path and all the columns are included. Review the automatically detected types. You can see integer. These are all integer values, fine. These are all decimal values, these are fine. Then again, this is integer value. So this is also fine. We'll click next. Okay. So here we can see the all the data types, then schema, data source. So these are related to our data asset. Now we have to click create and it is creating data asset. Now this data asset is created. We have to select this bike rental and click next. Now in the task setting for regression, we have to select task type as a regression, which is there. Data set, we have to select bike rentals, which is already here. Next, additional configuration settings. Target column would be rentals. We are trying to find the rentals, right? So we are trying to predict what would be the rentals for a given day or date. So the target column would be rental. Next, in additional configuration settings, primary metrics. Let's click on view additional configuration settings. In the primary metrics, normalize root mean square error. So select normalize root mean square error. Then keep the explain based model unselected. Use all the supported model, it should be unselected. Allowed models, select only random forest and light GBM. So random forest and light GBM. These are the allowed models we are selecting. So normally you would want to try as many as possible, but each model added increase the time it takes to run the job. So we'll just limit our allowed models to random forest and light GBM. Then save this, expand limits, and in the limits we have to set trials to 3, maximum trials, maximum concurrent trials also 3, maximum nodes also 3, and metric score threshold we have to keep 0.85 so that if a model achieves a normalized root mean square error metric score of 0.085 or less, the job ends. Then timeout would be 15 and this is in minutes, 15 minutes. Iteration timeout 5 minutes. Enable early termination, it should be selected. So if our model training is done and job completes early, we can terminate the job. Next, validation and test. In the validation, we have to select train validation is split. That should be our validation type. So we have to give some training data, then use some validation data for validation of the model. Okay. So training and validation set would be created out of our data. Then percentage of validation data should be 10. So 10% of our data would be used for validating the trained model. Rest 90% would be used for training the data. And then test data is none. Click next. Now we have to create compute. Basically, this is where all this ML automated job will be running using this compute resource. So select compute type as serverless and we'll be selecting CPU for compute resource. It will cost us less. Okay. And then we'll keep the virtual machine tier as dedicated and we have to select standard DS3 version 2 4 cores with 14 GB RAM and 28 GB of storage, which will cost us $0.29 per hour. And the number of instances will keep 1. Then click next and we can review all the settings that we have done. Basic settings, what would be the auto ML name, experiment name, description. Then task type and data. It's a regression model we are creating with bike rentals data set. Then task setting is we have to find out the rentals and these are the limits of the job being run along with the timeout settings and maximum trials. Then validation type would be train and validation. So 10% of the data would be used for validation and rest 90% would be used for training. And then compute engine that we are creating to run this ML job. So Azure Machine Learning serverless compute. Okay. And it is a CPU based dedicated resource, a virtual machine with a standard DS3 version 2. And we have only one instance of this. Now we'll submit training job, and here we are seeing submission of job. Let's close this one. And now wait for the job to finish. To make it might take a while. Now might be a good time to take a coffee break. So you can take a break. Currently the job is not started. Currently it's provisioning a compute engine. Then it will submit the job and it will start running the job. So here we can see the status. Now it is running. This is the Azure ML bike rental instance 1 job. So we'll pause here, and once this job is completed, we'll continue from there. Here we can see it is setting up the run, and then subsequent step it will perform on our data set to run the automated ML. Now we can see it's running featureization, and again we can see validating run configuration. Now we can see model training, and now we can see our automated machine learning job is complete. We gave a exit score of 0.85, and that has been reached, so the job was stopped. Okay, and we can see the ML automated ML job or machine learning job is completed. The duration it took is 9 minutes 47 seconds. We also got the notification like automated machine learning job in the experiment MS Learn bike rental. This was the experiment name we configured. So it's completed now. Next, review the best model. So when the automated machine learning job has completed, you can review the best model it trained. On the overview tab of automated machine learning job, note the best model summary. So here, best model is light GBM, okay, with these actually max absolute scalar and light GBM. These are the two models with best model summary. So select the text under algorithm name and the best model to view its details. So if you click on this, we can see these model summary. Select the matrix tab and select the residual and predicted true charts if they are not already selected. So select on this matrix tab and we can see explained variance, mean absolute error, all these parameters and the values we can see here, different matrices values. Okay, and then you can see predicted true value. It's increase here, then again decrease, and then here increase again. So predicted versus true value. Okay, so the predicted value is this solid line, and the ideal value is this dashed lines. And then in the residual chart, we can see residual histogram. So review the charts which shows the performance of the model. The residual chart shows the residual, the difference between predicted and actual value as a histogram. The predicted true chart compares the predicted value against the true values here. Now, deploy and test the model. On the model tab for the best model trained by your automated machine learning, select deploy and use the web service option to deploy the model with the following settings. So where we have to go? Go to models here. Here we see deploy and deploy as web service. We can real-time endpoint. We can deploy as a real-time endpoint. Okay, we can set it as a batch endpoint. batch endpoint. Deploy the model using the batch endpoint wizard. And then we have web service. So deploy the model to a web service. So we'll select this one. So now let's deploy our model as a web service. So we have to give the name of our web service model web service. Then put predict cycle rentals. That should be the description. And Azure container instance would be the compute type. So under container, this web service will be hosted. Then enable authentication selected and wait for the deployment to start. This may take a few seconds. The deploy status for the predict rentals endpoint will be indicated in the main part of the page as running. Wait for the deployment status to change to succeed. This may take 5 to 10 minutes. Okay. So let's click on deploy. And now we can see currently the endpoint is getting deployed. Here we see deployment status as running. Once it changes to succeed, then we can test the deployed service. Okay, so moving on to the next step. Once the model is deployment is success, then we'll start testing the deployed service. Now we can see deployment status is succeeded. So let's click on the deployment status and it will take us directly to the endpoints. You can see this in the sidebar as well. If you click on endpoints, you will see the ML model that we have deployed, and just click it and you'll be coming to this page, okay, where we'll have service ID, which is predict rentals. Deployment status is healthy, it's working, it's succeeded, and it's deployed or hosted in container instance. This is the model ID and created on this day. We have this endpoint here. Let's copy this endpoint. We will need this to work with. Also, there is a Swagger URI endpoint, and this is the CPU and memory of the container that we are using to host and run this service. Okay, so our model is deployed as a web service now. Now let's go to this hands-on. So now we have to test this deployed service. Okay, so in the input data to test endpoint, just replace the template JSON with this following. So let's copy this and we'll go to test tab. Okay, and let's paste this here. Okay, so this is the data we are giving now. Day, month, year. So 1st January 2022. Season is 2, holiday 0, weekday 1, working day 1. Weather situation 2, temperature 0.3, air temperature 0.3, humidity 0.3, wind speed 0.3, and global parameters is 1.0. So all these values we have set now. Now click test button and review the test result, which includes a predicted number of rental based on the review the test results, which include a predicted number of rentals based on the input features similar to this. Okay, so we are getting a result in this form. Okay, the test pan took the input data and used the model you trained to return the predicted number of rentals. So almost 365 rentals we have got. The test pan took the input data and used the model we trained to return the predicted number of rentals. That's around 365 rentals we are going to get. Now let's review what you have done. You used a data set of historical bike cycle rental and that data to be used to train a model, and the model predicts the number of bicycle rentals expected on a given day based on seasonal and meteorological features. So these are seasonal and meteorological features that we see here. And on 1st January 2022, that's the date where uh, on that day we want to predict how many rentals we'll get. So that is 364.78. That's around 365 rentals. Okay. Now cleanup. The web service we created is hosted on Azure Container Instance. If you don't intend to experiment with it further, you should delete the endpoint to avoid acquiring unnecessary Azure usage. So go to the Azure Machine Learning Studio. On the endpoint, select the predict rental endpoint, then select delete and confirm. So here on the endpoints, okay, go here, click here and delete, and this will delete the endpoint. To delete your workspace, just delete the resource group under which we have created machine learning resources, and this will also delete all the Azure machine learning workspace and related key vault, uh, application insights resource, and storage locations. Okay, so it will delete everything. So that's it for now in this video. We'll continue with our next video in the next session, which is about exploring computer vision. So stay tuned for more updates. Thank you. Bye bye.